Hello everyone, this is Asha from Sri Venkateswara College of Engineering. Today I am here to present you a video assignment on using microservices and artificial intelligence to analyze images in criminal evidence. So, before going through this, we'll learn what is AI, what is artificial intelligence. So, in today's rapidly advancing technologies landscape, AI has become a household term. So the artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think, reason, and learn like humans. Rather than being explicitly programmed for specific tasks, AI, which is artificial intelligence systems, uses algorithms and vast amounts of data to recognize patterns, make decisions, and improve the performance over time. So the paper on using microservices and artificial intelligence to analyze images in criminal evidence. So the abstract. With the advancement of digital crimes, the field of digital forensic science grows more and more, and with this growth, the search for faster and more accurate solutions to aid the investigation process becomes a necessity. So, the Brazilian judicial systems during a criminal investigation, forensic specialists extracted, decode, and analyzed the evidence collected to allow the prosecutor to make legal demands for a prosecution. The image classification module contains some pretended classifiers constraining the needs of forensic analysis of Rio Grande do Norte District Attorney's Office. So, introduction. In the Brazilian judicial system, for a prosecutor to establish legal requirements for an indictment, it is usually necessary that forensic specialists extract, decode, and make an analysis of collected evidences like cell phones, tablets, hard drives, etc. Commonly, the collected media consists of a large amount of data, while leads important evidences that helps to solve a crime are usually found in specific files. With the overall cheapening of data storage and technology advances, mobile device storage capacity has increased by a large margin in the past years. This results in more data present in these devices when they are apprehended. This platform was conceived to process big data in the context of criminal evidence and speed up the criminal evidence analysis procedures. So the related works which are done are there are many works related to object detection and classification tasks using AI, ML, and deep learning. So however, most of them focuses on specific objects. So in 2012 and 2013 proposed a biometric model using computer visions to detect and recognize tattoos in individuals. Those are a good instruments in forensic science for performing human identification. This refers to the fact of tattoos are registered at the time scratches, and burns. The dataset used by the authors contains 64,000 images of tattoos. They use CBIR, which is content-based image retrieval, an application that scans used databases to find images that have a certain resemblance to an input image. The images were used in supervised algorithms and they obtained results with an accuracy rate of 57%, which is enormous. Within the evidence data, an analyst will search for images that prove suspicious behavior. For example, by looking for fake and false images. Then we have 2005, we proposed a forensic images mining system using a modeling of component-based objects and scenes to detect and filter out indecent images. So this detection of images are done through CCTV recordings and many more. In their experiment, their methods achieved a false alarm rate of 7% while achieving a specificity of 95% and sensitivity of 81%. Even 2014 described the process of digital forensic and explained how the approaches digital forensic as a services developed in the Netherlands and forensic institution helps forensic analytic in the investigation. So the microservices architecture, this is an important thing. So digital evidence visualization tools demand much computational power. When running on a local machines, these tools can take too much time to load and even make the analyst computer unusable. Moreover, we can have thousands of images to be analyzed in an evidence which already could be very time consuming on a reasonable up to date computer could be even worse on a slow computer. As digital evidence have a large range of objects of interest, the image classification process of those evidence requires different applications or services. First, there are large quantities of data to be analyzed, and the metadata attached to each images is also very important to the forensic analysis, so it cannot be dismissed. Furthermore, there is also the problem of sequential image classification. Here is an inside architecture. We have imported module, and imported module is gone through the speed layer, which consists of n number of topics. Here we use Kafka, then the consumer. So the consumer is attached to the classification model. Here we have image classification API. Then we have OCR API, face recognition API, and detection API, and age range API. This all are connected to the topic. Serving layer. The serving layer contains of a relational database and front end web. It is important to notice the architecture described supports any kind of image processing or data extractions. We can simplify the natural approach of the following steps. So first, the working flow of the model begins from the message received by Kafka, consumer from the image topic. The consume message consists of an image that has yet to be classified and the image metadata. The message is then processed by the image classification API, where it will be processed by a deep learning algorithm. This algorithm is trained using a specific data set to detect the object. In this API, each image goes through a series of classifiers. If a relevant object is detected, the image receives a tag corresponding to the object class. It is possible for an image to belong to more than one class. So the important modules are extracted of pre-processing evidence data. The modules are XML format as an input. Then file contains two types of data: XML file containing all metadata collected from the evidence, and we have a directory tree with a variety of other types of data. The materials and methods used are datasets. When we use the software YOLO, you only lock once. Then to detect the image, we use it for real-time image detector. This tool is conventional neural network and addresses of detection task as a regressive problem. Then we use Inception V3 was developed based on the improve of Google Net architecture. So NeuroNet several deep learning libraries and large number of open source implementations and documents image classification is used, and face recognition, face detection consists of identifying patterns and characteristics present on the human face. Characteristics such as the shape of the mouth, face, and the distance between the eyes and the computer visions are, as already mentioned. Training process, screenshots, and documents classes, we use transfer learning implemented with the help of the TensorFlow library. Then the result evaluation of the process is separated into two parts. First, we will evaluate the image classification process. Then at the second, we will evaluate the use of the Apache Spark cluster in the classification process and access the difference between the serial image processing and images. We use screenshots and many other images to learn the data. So here is an example of image that could be sent to the classifier from internet. So when the image is sent, it detects so here you can see the example of here MO detected in a cartridge clip. So in the cartridge clip, the MO is detected. The bullets are detected easily through the AI. So MO detection of different sizes of MO. So MO detected in hand and in the cartridge clip. So here you can see a great example of MO detection. So firearms detected in a while analysis scenes from the movie Matrix, where the character has submachine guns, SMGs in his hand. Here the AI is detecting in the movie, it's a picture in the movie called Matrix, where he carries a SMG gun, which is also called a submachine gun. So where the AI is analyzing the image and it is detecting the ammo or the gun or the firearms. So the more firearms detected in the scenes from the movie Matrix are here. Here is a character holding a pistol, which is a small, tiny pitch is holding in his hand. So the AI is trying to detect the images by marking it in a square. So the firearm detected in a picture of a pistol being held by someone. So this is a pistol held by someone, which is AI is trying to detect it. So To conclude, this paper presents the inside image classification model built to extract evidences at the forensic laboratory and state. This microservices-based architectures allow the application to have a bigger flexibility regarding services it uses. So this can be used in the real world where the detection of the MOs or the detection of the guns are possible in the real-time CCTVs and any other public areas. As in the future work, we plan to improve the results obtained with the current classifiers and implement new ones. We believe that with more images, diversity, and more images, we can make the classifiers to be more precise and accurate. So these are the references used. We use the elsewhere publications and Tumblr.com then to learn about deep learning, how the deep learning is carried out, and how the machine learning is carried out, how the phone image detections is all carried out, and various examples. And thank you. Have a nice day.